Hello and welcome to this coding lecture. In this lecture we are going to work with tensors. So you can see here I've already opened up my Visual Studio Code and I'm working from my working folder, and I can go to File, New Text File, or I can just press Ctrl N, and then I'm asked to select the language, and we are going to say this is a Python script that we are going to develop. Right, you can see already this small icon here, which is pointing to Python. You can see here in the bottom right, this is the conda environment that we are going to use and that we have created earlier. So everything is set up and now we are ready to start. So we are working with chunks, so we can create chunks with this notation, hashtag %%, and then everything inside this area until the next chunk is starting is going to be executed. So the first chunk that we are going to use is dedicated to the packages, and in here we are saying we want to import Torch and we want to import NumPy as NP, the classical alias, and for some small visualization we are going to use Seaborn, and we are importing this with the typical abbreviation SNS. Alright, we can click on Run Cell and you can see that this interactive window is opening and that this code chunk is now executed. And once everything was run successfully, you can see this green check mark. Great, no error, everything worked. All the packages are found and can be loaded. Perfect. So we are up and running. So let's start very simple, and we are going to create a vector. And we're going to create a tensor. So let's call the tensor x, and that's going to be created by calling torch.tensor and providing a value 5.5. We can run that. So now we have created this tensor. We can do some very simple calculation. So for example, if we say the variable y is depending on x plus whatever offset, then we can also print our variable y. And you can see this is behaving very much like NumPy. Everything is the same so far. And one difference here is actually if we check the property requires grad, that is false. So if you create a tensor in that way, and if you don't specify the parameter requires grad equals true, then the default is actually that it doesn't require gradients. So let's move on. Let's create x again. So that's again going to be a tensor, and it's having the value 2. And this time we are setting the flag requires grad equals true. And then if we are checking that property x dot requires grad, then we are seeing, okay, this is now enabled. Great. What we are going to do now is that we are going to create a function for the variable y, and then first of all we are going to check how x and y are behaving, and then we are going to calculate the gradients, so basically the slopes of y versus x at specific points. So let's define our function and let's take a look at the function plot. So let's just create a function for calculating the y values, and we directly return the value -3 times value -6 times value -4. Alright, that's our function, and we are now just for visualization purposes, we are creating a range, which we call xRange, and we can call from NumPy the function linspace for linearly spacing for a certain range, and we want to have the range from 0 to 10 and 101 points along this line. And then we can calculate the y values accordingly. So this is basically just using list comprehension for each element. For each element I in the range of x, we are going to apply the y function that we have defined, and then we are saving everything in a list. And then we can plot what we have here. So we are having an x variable which is xRange and y is equal to yRange. And then you can see this is basically the function that we are going to work with. And we will see how we can directly calculate the gradients of our function at specific x locations with the help of PyTorch. Okay, so far we have defined our tensor x. Here we go with the gradients enabled. Now we are going to calculate y. So the same function that we have defined before is going to be used right now, and you can see here GitHub Copilot in action. So the proposal was perfectly right. We have now the same function here for the definition of y, and now we can call y.backward. And as you have heard before, this is the function to actually calculate the gradients. So once we call that, and then if we print the gradient of x, then you can see this is having the value of 14. This is basically the slope at the position of x equals 2. So it might not look like much, but it is actually quite cool, because all we have set up to this point is our two tensors, x and y. Y is a function of x, and just calling this function and we get the slope of x. So that's quite cool. And that is something that is going to be used a lot later on with the neural networks that we are going to develop. All we have to do then to calculate all gradients is basically calling the backward function, and then the complete computational graph is calculated. So that's quite awesome. Let's do it with a second example. Let's say we have defined x, and this is having the value 1, and requires grad is enabled. Then we are saying y. This is a function depending on x, and the graph goes on. Now we have another variable called z. That one is itself depending on y with whatever formula. All the values don't play any role here. All I want to show you is basically how everything interacts with each other. Now we can start with the last node of this, which is called z, and we are calling the backward function to calculate all the gradients. Let's run that. It ran successfully, as you can see here. And now in the next chunk, we can print our gradient with taking our object x and the property grad. And this is now returning the value of 5. So far we only had some very linear approach. We had a first node which is connected to the second node, which is connected to the third node. Now we are going to get closer and closer to a real network, meaning that we are having now two inputs. x11, which is going to be created by calling torch.tensor. It's having a value 2.0 and requires grad equals true. Then we have another node in the input layer. I'm already using the terminology of neural networks, although this is just a simple computational graph. So here we have now a tensor with a value of 3. And now we have the second layer. So here we have a formula. I just come up with certain values. You can also use different ones and then try to calculate how everything works together by calculating the derivatives. So let's say we have now the second node, which is defined as 2 times x11 squared plus 2 times x21. And then we have another layer. So this is our output layer now. We have 4 times x12 plus 3 times x22. So basically, if you would draw a graph based on that, or go back to the last slide set that I have shown on this, we have here 2 nodes on the input layer, then 1 hidden layer, and then the output layer with 1 node. Alright, so now we can at the end just call the backward function on our final node. And finally we can take our objects x11 and x21 and show the gradients for these. And then you can see here, these are the slopes at these positions that we have defined for this specific network. You can also go back to the introduction slide set and check the values. Or you could just modify everything and play with it on your own. So what I wanted to show you in this very first coding lecture was actually how simple it is to create some tensors and how the different tensors can be connected to each other, and then basically how the backward pass can be employed to get back the gradients of the variables. So that is bringing us very much closer to some real neural network. You have seen here the autograd functionality in action. And with this, I want to conclude this lecture. Thank you very much and see you in the next one.